Welcome to the ET335 Adders and VHDL Lab Part B. Okay, here's our next logic circuit we need to do, so let's convert it to a Boolean equation. So our first one would be A times B bar. This is going to be C plus D. This is going to be E plus F, and this is going to be G times H bar. And this, they're all going to be added up through our OR gate. So what do we got here? We got AB plus C plus D plus E plus F and plus G times H bar. So let's convert that to VHDL. So we're going to have not A and B and or C or D or E or F or not G and H. Okay, that would be and. All right, that looks good. Here is our Boolean equation and our VHDL equation and the pin inputs for our design. Here we're back at quarters with our last program, and we could start from scratch, but I think it'd be just as easy to go ahead and just modify this one. So first thing let's do is we're going to have to add all of our inputs. Okay, and we're just going to call the output X. And we could go ahead and just modify this. Okay, so we're going to have X, and we're going to have not A and B. All right, where do you have that? Not A and B or C. Okay, we have C or D. Let's get a little of this, and let's spread that out a little bit. And let's have an OR, E or F. Or and we have not or not G and H semicolon. All right, let's take a look at that now. Not A and B or C or D or E or F or not G and H. Good. Okay, I'm getting some error messages, so let's go into our pin planner here. And we have two C's. We have an S we don't need. And our C is going in the wrong direction. So let's get rid of that. And get rid of that and see if that will solve my errors, because it doesn't like us having two directions there. So let's go ahead and compile it. Good. Okay, let's open up our pen planner. And A should be, we're going to start at A, and it's going to be M2. So let's go to M2. M2 should be A. And input tri-stated, good. So the next one, B, is going to be U11. So let's go to U. And let's see, is that 11? It is. All right, so that one should be pen B. Input tri-stated, good. And the next one's going to be C, U12. And that's going to be C. Input tri-stated, good. And the next one's going to be W12. So let's go down a little bit to W12. And that's going to be D. Input tri-stated. And the next one's going to be V12. So let's go down right there. V12, and that's going to be E. And input tri-stated. And the next one's going to be M22. M22. And that's going to be F. And the next one's going to be GL21. L21, that's going to be G. And H is going to be L22. Excuse me, H22. Yeah, L22 is going to be H. Input tri-stated. And it looks like I missed a couple of them here. Let's fix them. Input tri-stated. Input tri-stated. And X is going to be R20. So let's go to R20. And that's going to be X. And he's going to be driving VCC. Good. So let's close out of this. And let's compile. Good. Okay, let's close out of our report here and let's go up to program. And we have an OR gate file and our USB blaster, so let's start. Good. Before we check our program and see if it works, first thing let's do is just go through and figure out how it's going to operate. So this is an OR gate. So any one of these gates are true, it's going to make it work. So A needs to be anything but a 1, 1. So 1, 1 is bad, and 0, 0 will not work, and 0, 0 will not work, and 1, 1 will not work. So if in order for it not to work, we need to put this code in. Pretty much everything else is going to work. As long as we have one of those gates true, it should work. Okay, I have all the switches set just like it should be for all. So A and B are high, C and D are low, E and F are low, and G and H are high. So that's the one condition that's going to turn this off. So if I switch any of these, we're going to get a light. Okay, so that's our exclusion pattern, and it's working.